Hi everyone! Today we're learning about redox reactions. So what is a redox reaction? A redox reaction is a reaction in which electrons move between atoms. As you can see in the drawing, there is an A atom and a B atom, and the pink electron which is moving from the A atom to the B atom.
When an atom loses an electron, another atom gains it. Atom A is losing an electron, which means it's being oxidized. Atom B is gaining an electron, which means it's being reduced. Two ways to remember which atom is being oxidized and which one's being reduced is OIRIG. Oxidation is losing and reduction is gaining. Also, Leo Delaine-Sezger, which means losing an electron is oxidation and gaining an electron is reduction.
Now we're going to go over the oxidation rules. There are 7 oxidation rules. The first is that atoms by themselves have an oxidation number of 0. The second is that monoatomic ions have an oxidation number equaling their charge. The third is that compounds are neutral, sum of the oxidation numbers must be 0. Here are some examples. The next rule is that polyatomic ions must have the sum of the oxidation number equal to their charge. Oxidation in the compound usually has a charge of -2, with an exception of peroxide where it is -1. In covalent bonds, hydrogen is +1. Lastly, if all else fails, use the periodic table.
Now we're going to go over some oxidation examples. First we have NO2, and oxygen is always going to equal -2. So you multiply -2 by 2, which gives you -4. And since the compound has to equal 0, you have to make nitrogen have an oxidation number of 4. And now there's 2 more examples if you need any.
Now we're going to move on to balancing redox reactions.
Our example for balancing redox reactions is going to be iron 2+ plus dichromate 2-, which yields iron 3+ plus chromate 3+. Before you do anything else, you have to determine the oxidation numbers. Oxygen is always going to be -2, so since it's O7, you have to multiply -2 by 7, which gives -14. Since the overall charge for the compound is 2-, you can't make it equal to 0, which means that Cr2 has to be 6+. Now you determine which one is being oxidized and which one's being reduced. Since Fe goes from 2+ to 3+ on the product side, and Cr is going from 6+ to 3+, it is being reduced and iron is being oxidized. The first step is that you have to write the half reaction. Fe goes from 2+ to Fe 3+, and dichromate goes from Cr2O7 2- to Cr3+. Now you have to balance all the ions. Fe, since Fe has 1 mole and Fe has 1 mole, they're balanced. And then for the second equation, you have to balance all the ions, which means that you have to have 2 Crs on both sides. But wait, there's more. Now we have to balance the oxygen. In order to balance the oxygen, we have to add water. Since dichromate has 7 oxygen atoms, we have to add 7 water molecules because each water molecule contains 1 oxygen atom. Now we have to balance the hydrogen. Since we added 7 water molecules, this means that we have to add 14 hydrogen atoms to the reactant side. Now we have to add electrons to equal the charges. Since F2 is 2+ and the product is F2 3+, we have to add 1 electron to make Fe 2+. For the second equation, the charge on the product side is 6+, and for the charge on the reactant side is 12+. This means that we have to add 6 electrons to the reactant side to make it 6+ on both sides.
All that's left is to clean up. The first step in cleaning up is you have to multiply the first half reaction by 6 to cancel out the 6 extra electrons in the second half reaction. The last step is you need to write the equation all together so that it equals 6Fe2 plus 14H plus Cr2O7 2 plus yields 6Fe3 plus 2Cr3 plus 7H2O. There are two types of redox reactions. One is acidic and one is basic. The equation we just did was the acidic problem. Now we're going to move on to a basic problem. Everything is the same until you add the hydrogens. For a basic solution, you need it to equal OH instead of H2O. So right now we are rewriting the equation where we added the hydrogens. So you would add 14OH to the reactant side to make it 14H2O, and then 14OH to the product side to make it 7H2O plus 14OH. You would then cross out the 14H2O and the 7H2O to be left with 14OH on the product side. This would leave you left with 6Fe2 plus 7H2O plus Cr07 2 minus yields to 6Fe3 plus 2Cr3 plus 14OH minus. That would be the end equation. I hope this video has helped you learn how to do redox reactions with both basic and acidic equations. Thank you for watching, and please make sure to like and subscribe.